Well guys, let's prove the standard formula for root x square minus a square. Well, the integration of it. And in the thumbnail, I've given guys two hints. Either to use this identity or to use the other identity, cos x squared theta minus cos squared theta equals to 1. Now, you can use the other, hint I gave you, but you'd have to deal with the negative signs. Although you'll still get the answer and it's not really that bad, but I prefer to use this. And if you want to try it on your own, please do. And I'm going to go ahead now. So, as you can see, we have a difference of two squares right here and also right here. But does that mean we simply put it here and figure it out? No, because here a is a constant, but here we have two variables. So what we can do is rearrange this such that we get sec squared theta minus 1 equals to tan squared theta, right? Putting it there, putting it here. Now we get variable square minus a constant square. 1 square is 1. But here we don't have 1, we have a, or a square. So we want a square. So simply multiply a square on both sides. You'll get a square sec square theta minus a square equals to a square tan square theta. So now we have minus a square, and on the left we have a sec theta, or a square sec square theta. So that means instead of x, we can simply put a sec theta and proceed further. So x equals to a sec theta, and now differentiate both sides. You'll get a sec theta tan theta d theta. So this integral becomes root x square, which is a square sec square theta minus a square into a sec theta tan theta d theta. Now we already know that is this, which is a tan theta whole square. Square root cancels, giving us just a tan theta. So we'll have a tan theta right here, and this will multiply with that. So that means we'll get integration of a square, which is a constant, we can put it outside, into sec theta into tan square theta. Now this tan square theta, we can just put it as sec square theta minus 1, which is sec square theta minus 1 d theta, and simply distribute that. We get sec cube theta minus sec theta d theta, and here also d theta. Ink is running out. So now we have to do the integration of sec cube theta, which I've done 2-3 times in the past. I'll give you guys the hint if you want to do it on your own. So this differentiate sec theta, integrate sec square theta, and you'll get your answer. Another hint is let I equals to integration of sec cube theta d theta. That will be helpful, but for now I'll just write it directly. It's equal to sec theta tan theta plus log natural of sec theta plus tan theta by 2 minus integration of sec theta d theta, which is just in fact log natural of sec theta plus tan theta. So here we can take 2 common, put 2 over here, this goes outside. A square by 2 sec theta tan theta plus, you have this something right here, you have the same things right here. So you have something minus 2 into something. So just 1 minus 2, which is minus 1, which is minus of that something, which in our case is log natural of sec theta plus tan theta. Now from this step on, if you guys watched my previous video, the exact steps are going to be as in this, except that this minus sign will just be positive in the previous video, and except for x square plus a square, we have x square minus a square. Those are the only two difference. The steps are the exact same with the exact same logic. So we begin with the fact, let's put it right here, with the fact that sec theta is equals to x by a, and sec theta in terms of the right angle triangle in basis of trigonometry is hypotenuse by base. So draw a right angle triangle. This is a, let's say, angle. This is hypotenuse, perpendicular, base. Base is A, hypotenuse is x. So that makes our perpendicular root over x square minus a square. So we have found our perpendicular, and all we need to find is tan theta. So tan theta is perpendicular by base, which is just root x square minus a square by base, which is a. Now let's just put it right here, equals to a square by 2 sec theta tan theta. Let's do it directly. Sec theta x by a into x, this thing. So in the denominator we get a square. So denominator we get a square, and in the numerator we get x root x square minus a square minus the log of, we can take 1 by a common from here, 1 by a x plus root x square minus a square, big bracket. Now distribute a square by 2, which is a square, or a square cancel. So x by 2 root x square minus a square, which is the first term, minus a square by 2. Now what you can do is use the log property that ln a into b is equals to ln a plus ln b, so that we get ln 1 by a plus ln of x plus root x square minus a square. But let's just distribute that for a square by 2, such that we get ln 1 by a, and minus into plus is minus, so minus log natural of x plus root x square minus a square. Now I always forget this, which is a very important step. After you compute all the integrals, write plus c. I tend to do it on the last step, which made me, well, fail these integrals 3-4 times. So plus c, actually plus c1, c1. You'll understand why. In this step we have this thing, a square by 2 ln 1 by a. Now this whole thing is just a constant because a is just a constant. What you can see now is we have a difference of two constants, which just gives another constant. So that means together they can return as another constant, right? So we can just in fact remove these terms, or remove this term, so that we get this, and represent by another term, let's say plus c, and that is our proof right here. So you need to remember some things like the integration of sec cube theta, and to know that to separate the ln ab by using this, and to know that the difference of two constants is just another constant. If you want to know how that works, watch my video on how constants work. Now if you learn something new, please like and subscribe. Thank you.